started.
So for each of these systems, we want to graph them and see what the solution is. For the first one here, I'll graph this top equation in blue. That's saying we start out going down 2 from the origin, is right there. From there we go up 3, rise 3, and we run 2. We'll draw our line through those points. Second equation, I'll draw in green. We got sort of positive 2 there. And from there, we got a slope of negative 2. We go down 1 and run 2. And once again, we're lucky enough that the slopes collide on us. And we get a solution here. That is at 2, 1. So the solution to that system of equations is that ordered pair, 2, 1. X equals 2 and y equals 1. Well, over here, we have to solve for y, so I'll do the bottom equation here first. I'm going to subtract 2x, so I've got 3y equals 6 minus 2x is just that, 6 minus 2x. And we'll divide by 3. So dividing by 3 on the left side just cancels out the 3, leaving us with y. On the right side, we have to divide each digit by 3. So 6 divided by 3 is 2. Negative 2x divided by 3. Well, negative 2 divided by 3 is just negative 2/3. Then we have the x there. So to graph that one, we're going to start at positive 2. Negative 2/3 means we go down 2 and run 3. So there is the second point on that line. For that top one, we'll move it over here. 3x plus 2y equals 14. We need to subtract 3x. So we have 2y equals 14 minus 3x. Then we'll divide by the 2. So on the left side, 2y divided by 2, the 2's just cancel out. So if y equals 14 divided by 2 is 7. Negative 3x divided by 2 is just a negative 3 over 2x. So we start out here at positive 7. And from there we go down 3, run 2. Get our second point. Let's do that again. Down 3, run 2. Let's keep going. So down 3, run 2. And that looks like we're hitting the other line there now. So it looks like that point of intersection there, I'm a little off. Should be right about there, actually. I'd say that point of intersection looks to be at, actually, no, I was about right the first time. Looks to be at about 6, negative 2. Now that one's a little bit of a guess, so let's double check it by substituting it back in those equations and making sure that 6, negative 2 makes both of those equations true. So 3x plus 2y equals 14 is going to become 3 times 6 plus 2 times negative 2. And we're checking to see if that equals 14. Now it's just order of operations. 3 times 6 is 18. 2 times negative 2 is a negative 4. 18 plus a negative 4 is 14. So we have 14 on both sides. Let's check the other equation there. 2x plus 3y. So that's 2 times 6 plus 3 times negative 2 equals 6. Again, we do the order of operations. The 6 On the right side, there's nothing to combine, so it's just going to stay 6. On the left side, we have to multiply first. We're going to go left to right. 2 times 6 is 12. 3 times negative 2 is a negative 6. And 12 plus negative 6 is 6. So we do get 6 on both sides. So that point
Recording is on.
2 satisfies both equations. So it is a solution to that system of equations. Somebody just came in as their microphone on. If you want to mute for us, please. So as we mentioned yesterday at the end, these graphs are okay if we have nice integer solutions like 6, 2 and 2, 1. But even then, we have to be very careful to get them to work out. It's much easier if we could just work with the numbers, do them algebraically, and calculate the answer instead of trying to graph them out and see where the lines cross. So we did an example yesterday similar to this. We know that in those equations that the solution to the system, that this y and this y are going to have the same value. In fact, we found that value. It's going to be a 1. But even if we didn't know that yet, we could combine them. We could substitute this y in for that y. Well, what do I mean? Well, if this y equals 3x minus 2, or 3 over 2x minus 2, we can put that in here for that y. So 3 over, instead of y equals, in this bottom equation, instead of y equals negative 1/2 x plus 2, we're going to have 3/2 x minus 2 equals negative 1/2 x plus 2. And now we have to solve this equation. First thing we're going to have to do is get rid of one of the x's. There's nothing to combine on either side here, so we have to get rid of one of the x's. Negative 1/2 is the smaller one, so I'm going to add 1/2 to get rid of a negative 1/2. So I add 1/2 x to the other side as well. It has to be added to the 3/2 x. Now 3/2 plus 1/2 is 4/2, or just a 2x. So if 2x minus 2 equals positive 2. Now we're in a form that we can just solve. Add 2 to both sides to get 2x equals 4. And we'll divide by 2. Get x equals 2. Now that's just half of our answer. We know that x equals 2. We would still need to find y. So we can go back up to either one of the equations. I'm going to go to this top one since it's a positive 3/2. Y equals 3/2 x minus 2. I'm going to put this 2 for x into that equation and see what I get for y. So y equals 3/2 times x. Instead of x, I'm going to put in the 2. And then 3/2 times 2 is 3. Y equals 3 minus 2, or y equals 1. So our solution is that ordered pair x equals 2 and y equals 1. Now let's look at this other equation here. 3x plus 2y equals 14. And 2x plus 3y equals 6. We weren't really sure of our answer after we graphed it. So we plugged in the answer and we double checked it, and it did work out. It was a solution to both equations. But let's look at how could we solve something like this algebraically. It's not y equals like all the other system was, so we can't just I can't just put the two equations together. What we need to do is we need to pick a variable to solve for. Now to do that, we want to pick a variable that's not going to give us ugly fractions or decimals. So what do I mean? Well, let's look at this top equation here. If I were going to try to solve for x there, at some point I have to divide by 3. Dividing by 3 gives us ugly fractions or decimals. Dividing by 3 gives us repeating decimals if we're going to go decimals, or we'd have to work with the thirds, the fractions. But if we divided by 2, or if we solve for y, we would be dividing by 2 at some point. Dividing by 2 isn't bad. The worst that can happen is we get a decimal of a 0.5. So let's solve that top equation. I'm going to label these equations A and B. We're going to solve equation A for the variable y. Like I said, we're doing that because y has a coefficient of 2, so when we solve it, we're going to be dividing by 2, which is going to give us, not going to give us any really weird repeating decimals. So to solve that for y, I'm going to subtract 3x. So I get 2y equals 14 minus 3x. This is going to look very similar to what we did for graphing here. Then we're going to divide by 2. So y equals 7 minus 3/2 x. So I solved that one for y. Now I could solve this one for y as well and just put them together like I did up above, but I don't need to do that. And also here, because it's a coefficient of 3 on the y, dividing by 3 is going to give me ugly repeating decimals. I don't want to deal with that. So what we're going to do is we're simply going to take this expression here for y equals 7 minus 3/2 x, and we're going to rewrite this equation here, replacing y with the 7 minus 3/2 x. So 2x plus 3, and in place of y, we put parentheses, 7 minus 3/2 x equals 6. Now you'll notice we have, excuse me, we have an equation here with only one variable. It's only the variable x. We know how to solve those. Even though this one's a little bit ugly, we can still solve it. So here we're going to combine what we can on either side. So on the left side, I have to multiply by the 3 through the parentheses. So that 2x is not going to change. Positive 3 times 7 is a positive 21. Positive 3 times a negative 3 over 2x. Well, that's 3 over 1 times 3 over 2, which is 9 over 2. Let's see. Positive times a negative is a negative. 9 over 2 x equals 6. Yeah, I haven't done anything on the other side. So on the left side here, we can still combine 2x and negative 9 over 2x. 2x and a negative 9/2 is 4.5 x. 2, positive 2 minus 4.5, or positive 2 and a negative 4.5, gives us a result of a negative 2.5. So that's a negative 2.5 x. Still have the plus 21 equals 6. Now I've combined everything I can combine on both sides. The variable is just on one side, so we can go ahead and solve. I'm going to subtract 21. So negative 2.5x equals a negative 15. And then I will divide by a negative 2.5. So the negative 2.5 divides out on the left side, giving me x. Negative 15 divided by negative 2.5. Well, negative divided by a negative is a positive. 15 divided by 2.5 is 6. So we get x equals 6. Now again, if you weren't sure about that, negative 15 divided by negative 2.5. Well, we make this negative 15 over 1 divided by negative 2.5. 2 times 2 is 4 plus 1 is 5 halves. So the negative 15 over 1, we're going to change it to multiply by the reciprocal of 2 over negative 5. Both 15 and negative 5 can divide by negative 5, giving me a positive 3 and a positive 1. 3 times 2 is 6. 1 times 1 is 1. So that's where we got the x equals 6. Now we still need to find y. We have solved for y in this equation, so we just as well use it. We know that x equals 6, so y equals 7 minus 3 over 2 times, instead of x, we'll put in 6. 3 halves times 6 is 9. So this is y equals 7 minus 9. 7 minus 9 is a negative 2, so y equals negative 2 is our result for y, giving us the ordered pair 6, negative 2. Well, that's what we had just found from our graphing. So that confirms that answer. So let's look at a system that we have not previously solved. Let's go 3x plus 2y equals 4. And 2x minus y equals a negative 9. So, to solve this with substitution, we have to solve one of the equations for one of the variables. I'm going to label them equations A and B. If I look at them, I see that in equation B here, y has a coefficient that's actually a negative 1. So if I solve for y, I'm going to end up dividing by a negative 1, which gives me really nice, clean, actually integer coefficients. It won't even give me a decimal. So let's solve equation B for y. So 2x minus, we're going to put in the negative 1 there, minus 1y equals negative 9. We're going to solve by subtracting 2x. So the 2x is gone on the left side. Negative 1y is all that's left on the left. Negative 9 minus 2x is just that, negative 9 minus 2x. We'll divide by a negative 1. Get rid of the negative 1, so y equals negative 9 divided by negative 1 is a positive 9. Negative 2x divided by negative 1 is a positive 2x. So equation B is y equals 9 plus 2x once we've solved it for y. Now we do have to remember that's equation B, because now we have to put it back into the other equation. We have to make sure we put it into the other equation, in this case equation A. So we're going to replace y with 9 plus 2x. So we're going to rewrite equation A here, 3x plus 2, but instead of y, I'm going to put in 9 plus 2x, because y equals 9 plus 2x. Close the parentheses, and that equals 4. So now we have an equation with only one variable, and we need to solve it, in this case, for x. So we're going to combine what we can on each side. On the left side here, we have parentheses. Nothing to do inside them. So we're going to multiply by the 2. So the 3x is just going to stay there. 2 times 9 is a positive 18. 2 times 2x is a positive 4x. That still equals 4. Well, I can still combine more here, actually. I have 3x and 4x. Give me positive 7x. Still have the plus 18. Equals 4. Now, we can solve. We'll subtract 18. 7x equals 4 minus 18 is a negative 14. And we'll divide by 7 to get x by itself. X equals 14 divided by 7 is a negative 2. Now we need to find y. I could go back to one of my original equations if I wanted to and put in that x equals negative 2. But I have this equation b over here that I've already solved for y. I've done a good share of the work. So let's just plug it in there. Y equals 9 plus 2x becomes 2 times negative 2. So order of operations, 2 times negative 2 is negative 4. So y equals 9 plus a negative 4. 9 plus a negative 4 is 5. So y equals 5. So our solution here is the ordered pair, negative 2, comma, 5. Just like we did with graphing, if we wanted to, we could go back to the original equations and make sure those numbers worked. Negative 2, 5. Well, 3x plus 2y becomes 3 times negative 2 plus 2 times 5. Check to see if that equals 4. 3 times negative 2 is negative 6. 2 times 5 is 10. And negative 6 plus 10 is 4. So we have 4 on both sides of that equation. For the second equation, 2x would become 2 times negative 2 minus y, which is 5, equals negative 9. So 2 times negative 2 is a negative 4. And negative 4 minus 5 is a negative 9. So we have negative 9 on both sides of that equation. So it works in that equation as well. So that ordered pair, negative 2, 5, makes both equations true. So that confirms that is the solution to our system. Now, one of the things that I need to stress that makes this easier for us is when we start out here, picking the right variable to solve for. Here, we solve for the y in that second equation because it had a coefficient of negative 1. And we knew that dividing by 1 or a negative 1 can never give us a fraction or a decimal. So that gave us simple equations to use. If I had solved for the x in that first equation, I'd end up with either repeating decimals or fractions I would have to work with. It would still work out. It's just a lot more complicated to do all of our calculations if we have fractions or long repeated decimals in them. In fact, if it's repeated decimals, we have to keep them fractions. Otherwise, it's going to have some round-off errors in it. So I want you guys to try a couple here in your notes. Let's do 5x minus 2y equals 16. And 2x plus y equals 1. So in your notes, I'm going to give you about 3 minutes to solve that, and then we'll go over it. Let's take a look and see how you're doing here. So, if I label the equations A and B, just for quick reference, I'm going to solve equation B for y. Because there's not a whole lot to do. All I have to do is subtract the 2x. And I have y equals 1 minus 2x. It is solved for y. It is still equation B. Now I have to put that into the other equation, into equation A. So I'm going to rewrite it, 5x minus 2. But instead of y, I'm going to put in 1 minus 2x. Equals 16. So now we have to combine what we can on the left side. We see the parentheses there. Nothing to do in the parentheses. So we're going to multiply by the negative 2. So we keep the 5x. Negative 2 times 1 is a negative 2. Negative 2 times a negative 2x. And negative times negative is a positive 4x. Well, still combining on that left side, we have 5x and 4x is 9x. We have the minus 2 equals 16. And we have to solve this now. We're going to add 2. 9x equals 18. And divide by 9. Get x equals 2. Well, that's only half our answer. We still have to find y. But we can go back to this equation B here that we solved for y and put 2 into that for x. So y equals 1 minus 2, and instead of x, we're going to put in 2. Y equals 1 minus 2 times 2. Order of operations says we're going to multiply the 2 times 2, gives 4. And then 1 minus 4 is a negative 3. So that gives us the ordered pair here. X is 2 when y is negative 3. So that's really the whole process of solving a system of equations by substitution. Like I said, we can make it easier or harder on ourselves by what variable we pick. Now, these two equations, no matter what variable we solve for, we weren't going to get more than one decimal place. Dividing by 2, the worst you get is a 0.5. Dividing by 5, you get a 0.2, 0.4, 0.6, 0.8. Neither one of those was going to be horribly bad. But it's definitely easier to solve for that y so we don't have any decimals or fractions at all. Well, I've been skimping on work time on you guys, so don't forget, by the way, there is a quiz out there. Quiz 12-7 out there that is due. There's also a quiz 1210A out there that's new that is going to be due tomorrow at noon. What is that? November 18th. That's on solving systems of equations with graphing. And your new homework for today is out of the big book once again. Pages 477, 478, exercise 17-2, problems 7 through 29, the odd. So we have about 11 minutes left. We'll let you have that time to start your homework. I will stay on the network here to answer any questions for a while if you like.